Hey everyone, and welcome to This Explainer. Today we're unpacking something that literally shapes our entire justice system, and it actually starts with a story from the year 1247. Just imagine this for a second. A man is found murdered by the side of a dirt road, and he has these distinct elongated slash wounds. The local official, a guy named Song Si, calls all the farmers in the village to the square and demands that they lay down their sickles. As the morning heat rises, flies begin to descend, and they land entirely on just one single sickle, drawn to the invisible traces of blood. The owner immediately buckles to his knees and confesses. This right here is the very first recorded instance of empirical forensics in history. And you know, it sounds brilliant, right? But it also begs a massive question about how we actually prove guilt. Okay, let's dive into this, because think about it. Anyone back in 1247 could have simply swapped sickles with their neighbor. Now, today, we don't have to worry about that, right? We're constantly told that modern forensic science is practically foolproof. It's supposed to be the ultimate truth machine. But is it really? We are going to look closely at whether modern forensics are truly as infallible as we're led to believe. Listen to this absolute bombshell of a conclusion. With the exception of nuclear DNA analysis, no forensic method has been rigorously shown to consistently demonstrate a connection between evidence and a specific individual. That is not just some fringe opinion. That's a direct conclusion from a massive 350-page report published by the National Academy of Sciences in 2009. This single document essentially invalidated decades of legal precedent and sent absolute shockwaves through the justice system. So what we have here is a huge gap between expectation and reality. On those procedural cop TV shows, forensic science is always portrayed as this infallible silver bullet. You know, the computer goes ding, and boom, the bad guy is caught. But the courtroom reality? It's actually plagued by shockingly high error rates and relies heavily on subjective human interpretation. To really understand how this happens, we're going to count down 5 famous forensic techniques, starting from the absolute least reliable all the way up to the supposed gold standard.
Section 1. Disproven sciences, hair and bite marks. Let's start at the bottom of the barrel and look at how microscopic analysis used to work. So before DNA testing existed, crime scene investigators relied heavily on microscopic hair analysis. They'd look closely at the rough, fish scale-like surface of a hair, or maybe how its pigment was distributed, and they'd try to match it to a suspect. Well, prepare yourself for this number. 96%. Out of all the microscopic hair analysis cases the FBI brought against defendants between the 70s and 1999, when they later went back and re-examined the evidence using modern DNA testing, 96% of the matches were declared completely false.
And this brilliantly illustrates the real-world consequences of bad science. This flawed analysis was used in 268 FBI cases. It resulted in 33 death sentences. Tragically, 9 people had already been executed by the time these errors were discovered. And honestly, perhaps the most shocking detail of the whole thing, supposed experts routinely couldn't even tell the difference between human hair and dog hair.
So yeah, hair analysis is out. But what about bite marks? Well, forensic dentist Dr. Mary Bush decided to actually put this to the test. Here's how her team did it. First, they used model teeth to create 89 bite marks on cadaver skin. Second, they compared those to bite marks perfectly cast in wax. Third, they compared the skin marks to a wider collection of 411 model teeth. And the result? 0 matches. None. Not even the original model teeth that made the bite mark match the imprint left on the skin. It turns out, human skin is just way too soft, squishy, and easily distorted under pressure to hold a reliable dental imprint. After 12 comprehensive studies, it was definitively proven that bite mark transfer to skin is simply not reliable. Yet, as Dr. Bush notes, the justice system prefers consistency and a historical precedent. Because of this stubborn clinging to the past, bite mark evidence, despite literally having 0 scientific reliability, was still being permitted in courts as recently as 2025. Moving up the countdown to Section 2. Flawed physics, bloodstain pattern analysis. Ask yourself, can physics truly rewind the clock on a messy crime scene?
This whole field essentially kicked off in 1971 when a chemist named Herbert Leon McDonnell published formulas based on tests he did completely alone in his basement. By the 1980s, courts all over the US widely adopted his methods, with some courts calling it so uncomplicated that they didn't even require proof of its reliability. It wasn't until 2014, we're talking over 40 years later, that the very first baseline reliability study was actually conducted.
And when scientists finally looked closely, they found a glaring error.
The initial formulas for plotting bloodstain trajectories used simple trigonometry, which assumed blood flew through the air in perfectly straight lines. They completely failed to account for two fundamental forces of physics, gravity and drag. Because of this massive oversight, early analysts were drawing entirely wrong conclusions. They'd assume a victim was standing upright, when physics actually proved they must have been sitting down. Even today, a large-scale study from 2021 found that analysts flat out disagree with each other on how a bloodstain was made 8% of the time. And part of the problem is just basic biology. Human blood viscosity varies wildly from person to person. For instance, men tend to have a 15% higher concentration of red blood cells than women. That makes their blood thicker, which completely changes how it spatters. Okay, let's move to section 3 and see how this builds. Conformity bias, the fingerprint flaw. We use them to unlock our phones, verify our passports. We've been told our whole lives that fingerprints are entirely unique and absolutely infallible. But are they?
The categorization system we use today started all the way back in 1890s Calcutta, where officers created 1,024 wooden pigeonholes to organize prints based on whether they had a spiral pattern called a whorl. Scotland Yard adopted this in the early 1900s. Now, fast forward to 2004, to the shocking story of Brandon Mayfield. After a tragic terrorist train bombing in Madrid, police found a finger mark on a bag of detonators. They ran it through a database and matched it with 100% certainty to Mayfield, a lawyer living in Oregon. The problem? Mayfield didn't even own a passport and hadn't left the US in a decade. He was entirely innocent.
So, how does an impossible mistake like that happen? Well, it comes down to how we actually process prints. We don't match whole, perfect fingerprints like you see in the movies. Human examiners must subjectively identify what are called minutiae. These are the specific, microscopic points where the ridgelines on a finger either split or end. And you need a minimum number of these minutiae just to run a database search in the first place. Now, what's really interesting about this slide is just how subjective this process is. Peer-reviewed research shows that looking at the exact same print, Examiner A might only see 3 minutiae, meaning they can't even run the search, while Examiner B might see 10 minutiae and run it successfully. Finding a criminal can literally depend on the luck of the draw of who gets assigned the file. In fact, if you give the same pair of prints to the exact same examiner twice, 10% of the time they will reach a totally different conclusion on their own work. And remember, that's just in controlled studies. In the real world, things are a lot messier. Notice that 42% slice right there. That represents the percentage of fingerprint analysis requests that explicitly state whether the suspect has a prior criminal record. Sometimes they even state the race and age of the suspect and the victim. This introduces severe conformity bias. When an expert knows the expected narrative, they can subconsciously force the ambiguous minutiae of a fingerprint to fit that exact story, which is exactly what multiple experts did when falsely accusing Brandon Mayfield. Section 4. The Paradox of Sensitivity. DNA Analysis. We've officially reached the climax of our countdown. This supposed silver bullet of forensics is incredibly powerful, but it actually suffers from a fascinating paradox. Its extreme, microscopic sensitivity is at the same time its biggest weakness. Back in the 80s, you needed a dime-sized drop of blood to get a DNA profile. Today, you need less than a pinhead's worth. And this leads to something called trace or touch DNA transfer. In 2012, California paramedics treated a hospitalized homeless man named Lucas Anderson. Later that same night, those very same paramedics responded to a murder. They accidentally transferred Anderson's DNA from their equipment right onto the murder victim's fingernails. An innocent, hospitalized man nearly faced the death penalty just because his DNA took a ride on a paramedic's glove. Furthermore, DNA can persist in dark, dry places for centuries. So if you swab a common object, like a doorknob, you are almost guaranteed to get a multi-person DNA mixture. Forensic scientists look at chunks of DNA called short tandem repeats, or STRs. But when you have overlapping STRs from multiple people, the data becomes totally chaotic. Just consider this analogy. Analyzing a multi-person DNA mixture is quite literally like trying to single out one specific voice when 5 people are shouting at you at the exact same time. You just can't definitively tell whose genetic peak belongs to who. So, the crucial point here is this staggering 69% failure rate. In a 2013 study, the National Institute of Standards and Technology sent a deliberately complex 4-person DNA mixture to labs across the US. A massive 69% got the analysis completely wrong. Only 10% got it right. And remarkably, only 21% realized the mixture was too complex and deemed it inconclusive. Right now, there are no strict national lower limits on sample quality.
The labs themselves just subjectively decide if a sample is too mixed to analyze. Section 5. Is it still science? After hearing all of this, you might honestly be wondering if any of this holds up. But look, the point of this explainer is absolutely not to bash forensics. We are undeniably far better off living in a world with these tools than in a world without them. I want to leave you with this really empowering thought. True science isn't about being perfect from day one. It's about continuously updating our conclusions when we get new information, and dedicated scientists are doing this work every single day. For instance, investigators are now using advanced fluid dynamics software to map complex 3D bloodstains, vastly improving accuracy over those old basement formulas. The scientific method is working. It's just doing what it always does, evolving. But here's the catch. The courtroom operates very differently than the laboratory. The law loves finality, while science demands revision. So I want to leave you with this to ponder. As scientific progress races forward to correct the errors of our past, with the stakes of human life and liberty so incredibly high, how much blind trust should we continue to place in the justice system's favorite tools? Thank you so much for exploring this with me today, and always keep questioning what you see.